Hello and welcome. If you've ever wanted to study the dark arts of malware development and be the ultimate hacker, then this is the tutorial. That will not get you to that stage at all. Nowhere near that stage. In fact, actually, what we're going to be doing instead is we're going to be building an absolutely basic ass bitch shellcode loader using the Metasploit Framework, and we'll be writing it in C++. It should go without saying that this is for educational purposes only. This super beyond white girl basic shellcode loader is not going to get past probably any home AV at all, even the absolute shittiest ones. Let alone it won't even fucking see CrowdStrike or anything real, ever. Those high end EDRs are going to absolutely blast the absolute shit out of this thing if we're to try to go up against that. So obviously, this is not going to help you if you have any less than desirable or nefarious goals in mind. You're not going to benefit from this at all. This isn't going to help you hack the FBI. This isn't going to help you hack your neighbor, your company, your ex, whatever. Go back to your shitty little hacking subreddits. Okay. And have fun in your mom's basements in your black hoodies, I guess. So if this isn't going to be useful for hacking your neighbor or the FBI or, unlocking the secrets of the Epstein files, what is the point of doing this? And the point for doing this is to just gain a basic foundational understanding of what I guess malware is and how it works, what it does. There's many different versions of malware. If you didn't know that, this is just a basic shellcode loader, which is just the easiest, I guess, first stepping stone into the deep world of malicious software development. But there's many real-world and legal case uses, such as red teaming, exploit, and vulnerability research. This could also maybe help you if you're looking to get into analysis or reverse engineering work. Kind of getting an idea of what it actually looks like. I guess I don't fucking know. The point is, there is actual use case scenarios for wanting to learn this, and also it's just cool and fun. So why C++ and not any other language? Well, because the CISA, in conjunction with the FBI, conjunction is that, yeah, I'm using that right, I guess, and the FBI have sort of soft banned C and C++ due to the lack of built-in memory protections that the language have. Again, this is like a soft ban. It's not actually banned. There's nothing illegal about using either C or C++. It's just strongly inferred by these two federal organizations that developers just don't use those languages anymore. Which is fucking wild that they would even think for a second that that these fucking organizations would waste time and money trying to transfer over all of their programs to something like Python to run their fucking shit. Anyways, I think that's funny and hilarious, and it's just a little unique fun fact. Alright, so the very first step in this lab is going to be that you need two virtual machines. You're going to need a Kali machine or any other Any other... That's not what I meant. There we go. Any other... You're just going to need two virtual machines. Kali would be obviously the easiest. It's every little hacker boy's favorite distro of Linux because it's the only Linux machine they've ever touched. And they would die without apt packaging. But it makes it easy for running these types of labs. You don't have to really install any types of tools. They're already there. And specifically what we're going to need the most is Metasploit. It doesn't really matter what your attacking machine, what operating system your attacking machine is. It just needs to have Metasploit on it, basically. And then your target machine should be a Windows 10 or 11 machine. I'm using a Windows 10 machine currently for this one, just because. Fuck you. That's why. What else? Oh, the two virtual machines should be able to communicate with each other. That is probably the most important part of this. Is they have to talk to each other. If they can't talk to each other, then this lab is doomed from the start, and you will get fucking nowhere. So if you don't know how to do that, I suggest learning how to do that first. Because otherwise you're screwed. The second thing we're going to need to do is in our Windows client is we're going to need to come into the settings, and we're going to need to absolutely decimate Windows Defender. Because, again, this is not going to get past Windows Defender in the slightest. It will delete our executable binary the second it even thinks about running. So basically, the main thing we need to turn off in this scenario is this real-time protection. Go ahead and just turn that off. Say, fuck you, Windows Defender, and yeah. And now, with that done, we can come over to our attacking machine, and we can start by... Let's start by setting the listener first. So let's just go... we're going to be using MSF console for that. Alright, so what is Metasploit? Metasploit is the world's most used penetration testing framework, according to Metasploit anyways. It is now currently owned by Rapid7. This has not always been the case, but it is now. There is now a open source free version, which is what comes with Kali and what we'll be using. And then if you're hardcore, you can buy commercial support. Essentially, what it is it is a synchronous C2, meaning that the listener that we're creating with this basic shellcode loader is it's going to need a constant stream of data back to our listener in Metasploit on our attacking machine. So it's very loud and noisy. If the connection dies, then it's kind of gone for good without rerunning the exploit. And I think it's possible to, of course, write recovery methods and stuff like that, but that is far beyond the scope of this lab. So yeah, it has it's very, very fast. So the constant stream of data makes it very responsive and quick and easy to use. However, it needs the constant stream of data to work. And it's also, again, it's very noisy. It's very noticeable. So it makes it kind of less ideal in real world red team engagements. However, it's not completely useless. It's just it has a smaller use case scenario. You have to be more careful with how it's used. Honestly, so I guess we should have wrote the fucking shellcode for it. It doesn't fucking matter. What matters is that our listener and our shellcode are using the same payload. And that's all that really matters, as well as our listening hosts and our listening ports also need to be the same. Those three things need to be the same in order for our shellcode to be useful and give us a connection, a reverse HTTP connection. So what we're going to do, first and foremost, is we're going to use exploit multi-handler, and you can just tab this shit out. It makes it really, really easy. We're going to set our payload to Windows. There we go. x64 interpreter reverse HTTPS. And now we need to set our L host to I just do eth0, so it's just going to set to the default Ethernet port of this machine for our listening host, and then our L port. We really shouldn't need to change this if you're going to use the same port. It's 8443, which should just be the default port that opens up for this. As far as I know, I think that's the default port. And then we can do a show options here at the bottom to just make sure that we have everything set correctly. And we do, so that's cool. And now we can just run tacj to run this listener as a job. And as it shows down here at the bottom, it'll tell you that it is now running in the background as job 0. The exploit has completed, but there were no sessions created, and blah, 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 blah. So now what we need to do is open up a second tab here on our terminal, and now we're going to use MSF Venom. And as you can see here, I could just tab this out, but to walk you through what we need is we need a tag P for a payload, and then the same payload we just set. So Windows, x64, interpreter, can't type for shit, reverse HTTPS, and then we need to set our L host. I like to capitalize it in here for some reason, and then you can do eth0, or we can actually type out the IP of this machine. And okay, I guess in case you are the absolute beginner, you don't know how to get that, you just type ifconfig, and you can see that the IP address for this specific VirtualBox machine, this the specific IP for this machine is right there. So that's what we need, and then we need to set our listening port to be the one that we set. And the listener, so again for me, is 8443. And then this is the most, well, I guess not the most, but also important, is we need to set the file type to be compatible with the language that we're working with, which is C++, so we need it to be a C file. And then we hit enter, give it a few minutes, and it generates our payload. And here's our shellcode. This is our shellcode. Nice. And so we're just gonna leave this here for now. You can also output it to a file if you wanted to by running tac-o, and you can output it to a file. You don't really need that right now unless you just want to save it, or if you're scared your virtual machine is going to die or something like that. And now what we need to do is, well, we need to go into whatever code editor of your choice is. I'm going to be using Visual Studio 2022 just because I have it. It's here, it's nice, ready to go. And we'll be creating a new console app, and we can name it We can name it something like Gilbert Godfrey. No, Gilbert Godfrey's Revenge. And we can now have our beginnings of our console application. Really cool, really easy. We're just going to go ahead and delete all these stupid bullshit default hello world comments. And the first thing we need to do is we need to include our Windows header file, which will give us access to the Windows API. So what we're going to need for this is we're going to need 4 APIs from the Win32 APIs. The first is virtualalloc. Then we're going to need RTL move memory. Then we're going to need to create a thread using create thread. And then we're going to find a way to keep the connection alive. To create the connection and keep the connection alive, we're going to need wait for single object. Well, what create thread creates the connection, and then wait for single object is what how long the connection stays alive for. So, starting with virtualalloc, we are going the API requires a pointer address to the data that we're going to be allocating to memory. Then it's going to need the size of the data and what type of allocation we're going to be making, which is going to be reserving and committing. And then we're going to need to set the protections that we need for this data, which in our case is a read, write, execute. Actually, let's paste in our shellcode, and then just right above it, let's actually set a virtualalloc returns as an LP void. So we're going to need a void pointer, and we'll call it execute. You can call it whatever you want. You can call it dingle dongle jangle bangle bongle, and that will work too. But for simplicity's sake, I'm just going to call it execute, because virtualalloc needs to be returned into or I guess just set to a variable. So to actually write it, the call to virtualalloc, we're going to call execute equals virtualalloc, and then we need to set the pointer address, which we just want the very first available at point in memory. So to get that, we'll set it to 0. Okay, so now we need to, the second parameter we need to set is the size of the data. And in order to get to the size of the data, we need to, the size of the data actually needs to be an unsigned integer. That we'll just call payload length or size. Payload size, I guess, would be more apt. No, I like when better. It's easier to type. Will be equals size of buff, and why buff? It needs to be buff because Metasploit by default spits out the shellcode into an unsigned character array of buff. So yeah, we just need to get the size of the data of buff, the data we need the size of, saving it to an unsigned integer, and then we're setting that here with the variable we just set it as payload length. Then we need the allocation type, which is going to be 2 that we need actually. Like I said earlier, we need to mem commit it. Wrong key. Mem commit it, and we need to pipe that commit over into mem reserve. And now we need to set the protection rights, and we need, again, read, write, execute. And there's I think there's a few different ways you can actually write this. I just like 0x40. It means read, write, execute. It's quicker to write, and I can't remember the other ones off the top of my head. And that's our virtual alloc. So now, in order to actually move this data, to move our shellcode over into that section of memory, we need to call RTL move memory. This one takes 3 parameters. It needs a it needs the destination. It needs the source, and it needs the size. So what we're going to need is the allocated buffer, the shellcode, and the size of the shellcode. So again, it is as we just did with our payload length. And this one is just going to be written as RTL move memory. And then we just need to set it. So we need to where to go? Where did the documentation go? There it is. Yeah. So our pointer to our destination, which will be execute. Oh my God! Can I type? So the destination again is execute. It's the virtual alloc that we just created is saved as execute. So the pointer to our destination is going to be execute. The source, which will be our payload. So buff. That needs to be our data. So it's a payload. And then the length of the data, which will be payload len. And that's RTL move memory. With that, we'll be able to move the data into the allocated memory buffer that we just created with virtual alloc. It's pretty snazzy, isn't it? All right, so next we need to give ourselves the ability to execute. And in order to do that, we'll be bringing in our third API, which is create thread. And create thread, first and foremost, returns a handle. So just like with virtual alloc, we need to have a variable to set it to. This one is going to be a handle because that's what create thread returns, and we'll just call it thread because this isn't going to be used in the real world. It is just for a lab and demonstration, so why not just call it thread? Anyways, create thread has a fuck ton of parameters, and 90% of them we don't give a fuck about at all. Most of this is just going to be set to 0. So looking at the API documentation, we see that it requires to set security attributes. We do not need this, so 0. Set the stack size. Actually, let me try this differently. Let's walk through this as I write it. Thread equals create thread. Okay, so yeah, the security attributes. Don't want them, don't need them, they can fuck right off 0. Set the stack size in bytes. So a size tease of the DW stack size. We just want this to be the default size, so again, 0. Okay, and then we need to actually start the process. So in order to do that, we just need to call, oh my god, op thread start routine, as it says in the documentation. And then we need to call this to execute. Because it's the location of the memory of the data that we need to create the thread for is located in our variable execute. Then we need to decide whether or not we want to use the alias memory LP void pointer or LP void. And we don't need that at all. We don't want that. We don't need that. So 0. And then we need to set when to start the process, and we want the start to process immediately, so 0. And then we need to set the LP thread ID. We don't want the thread ID. We don't need that. Don't want it. We can just kick it on out of the house and tell it to get a job. So 0. And now we have our thread. Pretty simple. So after we execute the payload, we need a way to keep the call alive. And this is because Metasploit as a C2 is synchronous. A synchronous C2 needs to have a constant stream of data. If the thread dies, if we lose the connection, we lose everything. So now we need a way to keep the call alive. So in order to do this, we're going to use wait for a single object, and this is the easiest fucking part of this one. it returns a D word, and so we don't need to set it as anything. We're just going to call wait for single object, and it needs 2 parameters. It needs the handle, and it needs a D word for the milliseconds. So our handle is what we set earlier, which is thread, which is tied to our create thread. So our handle is thread. And the keep alive time needs to be forever. It needs to be infinite. And there's a few different ways you can set this to infinite, such as just typing, infinite. Again, I like to break the space-time continuum by setting it to -1, because -1 does not exist in time. And that is pretty much it. So now we can save this. We can build it. We can go into our files. What did I call this? Gilbert Godfrey's Revenge. We built it in the debug, so it's in the debug. Okay. And as long as Windows Defender, specifically the real-time protection, has been turned off, we should be able to go and just run this and get it get a call back on our attacking machine. If you're on Windows 11, every now and then, uh, Windows Defender likes to perform its necromancy on real-time protection and turn it back on in the background. If you are on a Windows 11 machine for your target, and that is keeps happening to you, you can always just set an exclusion in Windows Defender to be your source files. It could be the or the repos or whatever, or solutions, whatever it's just named, wherever your malware is loaded. So with that out of the way, if everything is correct, we should be able to run this, and it should just hang just like that. It's hanging. With it hanging, that means the connection has been made and it is still active, so we can come over to our attacking machine and we see that there's a interpreter session 1 has been opened at our listening host, at our listening port, with the target IP address right here, and then you have the UTC time. So let's open sessions 1, and we can get UID, and we can see we have my Maldev Academy virtual machines host name, and then we can get a shell. We got shell, and we can see the directory of the solutions folder or source folder, and we can move around. We can see what all is see all's there, and look at our program, or look at our program's files and all sorts of other cool. Oops, we can't tab out in this one. We can't tab out here. But yeah, so there we go. We now have a very simple and basic shellcode loader. This will absolutely not, I'll say it one more time, it will absolutely not get past even the shittiest of consumer grade or at home or end user, whatever fucking home AVs. It's not going to get past any of them. I'd be very surprised if it did. It's not going to. It's just, that's not happening. So yeah, it's very weak. There's zero authentication. Everything is going to flag this as an interpreter, reverse shell immediately. The Metasploit Framework is synchronous. The data transfer is very quick and constant. And the constant, because of this being constant and quick, and it makes it very loud and noticeable. And if the connection dies, it's gone for good. So while it has some benefits in a real world red team or pen test scenario, it's not exactly ideal. You probably want something that's going to have a bit more offsets to it, something that's not going to be constantly shooting data out of a network onto a malicious foreign server. So, yeah. Thanks for watching, and I hope you learned something cool. So, see you in the next one. Oh. You see what I mean about threat protection just resurrecting from the dead as it was fucking running? That's cool.